work that we have and estimated what was reasonably achievable out of those, out of that potential. And for the technology options, it was roughly 80% achievable within the next 10 years, but for behavioural options, they thought it was only roughly 30% achievable within the next 10 years. And I wondered if you had some comments in terms of the implications.
Well, of course, I don't know the details of which technologies. I mean, what I do know is that because of the rate of turnover of boilers and houses and so on, it's going to take decades to get the technologies in there. Even 80% achievable by 2050, so it's very slow. In terms of behavioural change, this is a very difficult one. We just don't know. But for example, when I started working on transport 25 years ago, and I said, what small cars is that? It'll never happen. It'll really never happen. And yet, if you go to a place like Sweden and so on, it's going over the top. The number of young men who have driving licenses and cars is falling. Our rail transport is going up. And so we can get these changes going in the other direction. Predicting it is like predicting anything else, really. And a large part of it depends on, if you make trains nice and relatively low cost, if you make it pleasant to walk and cycle, you can have all sorts of impacts like that. If you make it more expensive to go and have a drink in Prague, then maybe less of that.
This connects to my question. I want to ask you whether the implication of financial markets and the impacts on the economy with your scenario wouldn't be useful. You should also imply these economic models and also financial market models to show, and then to come to this question of education, because I think
it's
a matter of education, because now we are no longer used to have a positive view on our global warming. I think this might change if we have even more clarity how this will in the short term affect the economy, but also in the long term. And this would have to be communicated. And communication in this sense, how would you communicate this in an international scenario? Because we were quite advanced last year, but then we had this invasion with shale gas and fracking and everything changed, and also the markets changed, so people wouldn't invest in green energy for a while. So how would you avoid these kind of incidences?
Well, we have sort of long-term trends and plans, and then we have these wobbles. All frack is going to solve it, of course it isn't. It may make things much, much worse because of methane emissions. We don't really know. Similarly, the oil shale, etc. So, international cooperation is really, really important. And we do have it, for example, I said about transmission systems. We have it in terms of energy standards for vehicles. We have a global vehicle industry now. And so we can address some things through regulation like that. And then, the political negotiations on trade and so forth. But I mean, there's no magic bullet on this. In terms of education, what I will say, I did a sort of energy and carbon model for UCL, which is rather scary, really, because actually academics are pretty bad, because they travel a lot, they fly all over the place to go and blabber. And so I'm very sceptical about how far you can educate people to stop doing these things, particularly like flying or buying big cars. I unfortunately think you need more stick than carrot.
Lots of questions. I just wondered, in terms of the supply and demand management model, have you looked at how much of a risk increasingly unpredictable seasonal weather patterns are in dealing with sort of supply and demand management?
In DynEMo, we're using sort of statistically synthetic way. But what you can do in there is say, give me a really bad day. And this bad day is where it's -5 centigrade, there's no wind, there's no sun. What do you do then? And of course you find, well, let's keep all our old coal-fired power stations for that kind of day. And then simply for a summer's day, you can say, oh, it's 40 centigrade, 45 centigrade. It's as sunny as it can be in astronomy. What do you do on that day? What sort of temperatures are your houses going to go up to? And then so you need to look at these critical peak episodes, if you like, and see how to manage them. And probably the most difficult one is overheating.
If you have sort of longer periods than a day, you know, extreme weather, you look to the point where the system sort of can't cope anymore.
Well, no. Basically, in here, I haven't investigated what happens if you have 10 cold days in a row. You can do it. But I think quite simply, we keep our coal and oil and gas stations. We have great big piles of coal for that period. You know, lots of the plant are going to be retired. Maybe we build some new stuff. But that is our emergency supply. It's inside our control. We've got this huge energy store, half a coal, whatever, for 10 days, whatever it might be. The more difficult thing, though, is if you have overheating in the summer and you don't have air conditioning, as we saw the heat waves a few years ago. Even if you have enough energy, you haven't got the means of controlling the temperature in the house. And there you might think about more micro design. You might have a safe room in your house, which you can keep to 30 centigrade even when it's minus 10 outside, and you can keep it below 30 even when it's plus 45 outside, just to protect yourself against these extremes.
Okay, before we go upstairs for a drink to celebrate Mark getting the prize for the maximum number of graphs shown in any seminar, I'd like to thank Mark for his presentation.